So to start with, we have this first question, that is when a glass rod is rubbed with silk, it, option A, gains electrons from the silk, option B, gives electrons to the silk, option C, gives protons to the silk, and D, gives protons to the silk. See, whenever a glass rod is rubbed with silk, electrons get transferred to the silk. So this is the conceptual question. You should know the theory. So the option B is correct here. Then we'll move on to the next question, numerical based question, that is the force between two charges is 120 Newton. Let me write the data here. F is equal to 120 Newton. So if the distance between the two charges is doubled, okay, so the force will be, see, let me consider this is the new force F dash 1 divided by 4 pi epsilon naught q1 q2 by 2r, distance has got doubled, whole square. Okay, so that is equal to, you will get 1 divided by 4 pi epsilon naught q1 q2 divided by 4r square. Okay, now this part is called Coulomb's force, F. See, you should know the theory part to solve CET questions like this. That value is already given, that is 120 Newton divided by how much? 4. So 4 3s are 12, so 30 Newton is the answer here. I hope you have understood this. Now we'll move on to the next question, that is 12 charges are placed at the corners of the 12 sided polygon, okay, and each charge is having value q. What is the net force acting on the charge q at the center? See, if I consider an example simpler than this, let me consider a square. Here there is a charge, so here one more charge is there, here one more charge is there, and here one more charge. So at 4 corners of the square there are 4 charges. If I keep one test charge here, what is the net forcing on this? It is 0. Why? Because this charge applies force on this in this direction, and this charge applies force in this direction. So forces are equal and opposite in direction, so they get cancelled. In the same manner here also, along another diagonal, this force get cancelled with this one. So option A, the net force will be 0, because here we have even number of charges placed at the corners of the 12 sided polygon, and the distance will be same, opposite forces will be there, all of them get cancelled, so that you will get 0 as the answer. Okay, option A is the correct answer. Next, moving on to, what would be the value of electric field at the center of an electric dipole? Okay, so here for this you should know some basic concept, that is what is electric dipole? See, electric dipole means equal and opposite charges separated by small distance, plus q and minus q. At the center, what is electric field? See, we have already studied that due to positive charge, electric field lines are radially outwards. If not, you have to study the theory part, otherwise you can't solve CET questions. Okay, now here we have positive charge and negative charge, it is radially inwards. For negative charge, electric field lines are directed radially inwards. If that is the case, at this particular point, electric field due to positive charge will be in this direction, and due to negative charge is also in the same direction, because due to positive charge radially outwards, from here electric field lines will be radially outwards, and for negative charge the electric field lines will be inwards. So E plus and E minus are in the same direction, so E plus E minus are having the same value, so we'll get 2 times that value E. That's why the option electric field at the center of the dipole is twice the electric field due to 1 at the center. Okay, so here electric field due to positive charge and electric field due to negative charge will be same, so if you add them you will get 2 times of that. Next, we have two charges of equal magnitude kept at a distance r exert a force F on each other. If the charges are halved, see here the data is the charges are halved and the distance between them is doubled, then the new force will be, very simple question. See, let me write F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square is the Coulomb's force. But if the charges are halved, means Q1 is Q1 by 2, Q2 is Q2 by 2, and distance R is 2R, getting doubled. So we will get F divided by 16, because here we have 2 and here 2 square is 4, 2 2s are 4, 4 2s are 4 4s are 16. So we'll get F by 16 as the answer. Okay, hope you have understood this. Now we'll move on to the next question. That is, the electric field inside the spherical shell of uniform surface charge density is, see, it is a spherical conducting shell. It should be spherical conducting shell. So if you consider a spherical shell like that, okay, so let me consider the radius of this particular shell is how much? It is R, and at a point outside the electric field is given by 1 divided by 4 pi epsilon naught Q divided by R square. This distance is considered R, and the charge will be on the surface. So on the surface, electric field will be sigma R square divided by how much is that? 2R, or you can consider like this: E is equal to 1 by 4 pi epsilon naught sigma A divided by R square. So 4 pi R square, R 4 pi will get cancelled, means 1 divided by 4 pi epsilon naught sigma into 4 pi R square is the area of the sphere, which is having radius R, divided by R square. 4 pi will get cancelled, and resultant will be the electric field on the surface. But inside, electric field will be 0. This you must have studied in the derivations, applications of Gauss law. So that's why here the answer is 0. Inside the spherical shell, the electric field will be 0. Next, we have this question, that is, the electric field intensity at a point situated 4 meter from the point charge is 200 newtons. Okay, so there is a electric field whose value is 200 Newton per coulomb or units. Okay, so can I consider it as 1 divided by 4 pi epsilon naught Q by R square? Here the R value is given 4 meters whole square, and they are asking you to find out the electric field when the distance is 2 meters. See, the electric field at a distance 2 meters is, if the distance is reduced to 2 meters, what is the electric field? That we need to find out. Let me consider, that is E dash is equal to 1 divided by 4 pi epsilon naught Q divided by 2 square, because distance has reduced to 2 meters. Now let us divide E dash by E. So you will get 4 pi epsilon naught cancel out, Q will get cancelled. So then E dash value you are having 1 by 2 square, that is 4. Its value is 1 by 4 epsilon naught Q by this 2 square is 4, right? Yeah, divided by 1 by 4 square is 16. So that is equal to 4 4 is 16, 4 times. So 4 times means I will get E dash is equal to 4 into E. So that is E dash is equal to 4. What is the electric field given? 200 units. So that is 1000. It is 800 newtons. Actually, here I think something is missing. The unit should be Newton per Coulomb. It should be Newton per Coulomb, because here they have asked you to calculate the electric field intensity. Newton per Coulomb, new electric field intensity. So it should be Newton per Coulomb, Newton per Coulomb, Newton per Coulomb, and here Newton per Coulomb. Okay, so this is all about this. So you should have some mathematics knowledge to solve numericals like this, and also the prior knowledge about the subject is very much required. Yes, next we'll move on to this question. So two positive point charges are placed at a distance small a apart and whose sum is q. The sum of charges is q. Okay, so let me consider, here there is a charge q1, here there is a charge q2. They are separated by some distance a, not r, it is a. Now their sum q1 plus q2 is equal to how much? Capital Q. What values of the charges for what values of the charges Coulomb force between them is maximum? For which particular division of charges, means what should be the value of q1 and q2 so that force become maximum? See, force the electrostatic force of attraction and repulsion between two charges is directly proportional to, what is that, q1 into q2 divided by r square. Here it is a square. Okay, since a is constant, here a is constant, 1 by 4 by epsilon is constant, so force is solely dependent on q1 into q2. Multiply q1 and q2s, and where you get maximum q1 into q2, that will be the answer here. So in the first case, q1 into q2 is given by q by 2 into q by 2, that is capital Q square by 4. Second case, q1 into q2, how much is that? 3q by 4, q by 4 means 3q square by 16. So this is less than a. So third option, that is C, q1 into q2 is equal to 5q square by 36. So option A is having maximum value. So q1 and q2 values should be half of the sum. That is option A is correct. Do remember this, the force between the two charges is maximum when the total charge is divided into half or equally they are divided, then only you get maximum force between the charges, otherwise no. Yes, next. A cylinder of radius r and length l is placed in a uniform electric field parallel to the cylinder axis. The total flux through the surface is given by. Okay, so here let me consider the cylinder like this. Where is the cylinder? Here. Okay, and yeah, so now if I consider some electric field lines along the axis of the cylinder, what is the total flux through the surface? It is 0. It is 0. Why? Because number of field lines entering the surface are equal to number of field lines leaving the surface. Okay, that's why electric flux through the surface is 0. Next, electric field at a point varies as r power 0. R power 0 means it is 1, means it is not dependent on r. For which of the following cases? So an electric dipole. For electric dipole, electric field is given by let me consider it is electric field along the axis. It is given the list of formulas. If you have list of formula, you can easily get it. That is 1 by 4 pi epsilon naught 2p by r cube. means electric field is inversely proportional to R cube. For which one? For electric dipole. And for plane sheet, electric field is given by sigma by epsilon naught or 2 epsilon naught. Yes, for point charge, electric field is given by 1 over 4 pi epsilon naught q by r square. And for line infinite charge, electric field is, what is the derivation? Lambda divided by 2 pi r epsilon naught. So here electric field is inversely proportional to r. Here electric field is inversely proportional to r square. Okay na? So that's why here the one which is independent of r is in this case. So option C is correct. Option C is the correct answer. Why? Because in this case electric field is not dependent on R. Next, a metallic solid sphere. So this is this comes under the applications of Gauss law. Spherical conductor. Yes, let me explain this. A metallic solid sphere of radius capital R is given a charge capital Q. Which of the following statements is true? Okay, so here for R value less than 0, less than capital R till the center, maybe it is 0. So the electric field is 0. Yeah, this is correct because electric field inside the spherical shell is 0. If I consider spherical shell here, so this is the radius R. R value less than capital R means it is inside. Inside electric field is 0. It is correct. Electric field at R is greater than capital R means it is outside. Electric field is given by Q by 4 pi epsilon naught into R square. It is also correct. Then electric field is perpendicular to surface. That is also correct. If you consider any surface which is charged uniformly, okay, like this, so electric field will be radially outwards and perpendicular to the surface. So that's why all the options given are correct. So can I consider option D is the answer? Yes sir. Yes. Next, moving on to this one. What is that? A point charge Q is located at the center of the cube of edge A. Find the final electric flux over one face of the cube. See, a point charge Q is located at the center of the cube of the edge A. So there is a cube here. Let me draw a cube. For this you should have learnt the concept of Gauss law. So the charge is placed at the center of the cube, which is having edge A. So let us not worry about that length of the edge. The final electric flux over one's face. What is the flux through this face? Okay, that we need to answer. So here there is a charge. Electric flux through each face is given by Q by 6 epsilon naught. So that is option B is correct. Okay na? Yes. Next, we have a point charge Q is located at the geometrical center of the cube. The total flux through the cubical surface, it is actually, if we consider the total cubical surface, electric flux will be Q by epsilon naught. It is a direct question. There is option A, Gauss law. This is nothing but Gauss law. G-A-U-S-S law. Yes. Yeah. Next. See, 14th question. Two large metal sheets having surface charge density plus Q and minus Q are kept parallel to each other at a small separation between separation of distance d. The electric field at any point in the region between the plates is. There are two large metal plates or sheets having surface charge density plus q and minus q means one plate is positively charged and the other plate is negatively charged, kept parallel to the each other. So the small separation between them is t. So if you consider here, this is one plate and this is another plate. This is positively charged, this is negatively charged. So surface charge density plus q and here it is minus q. So what is the electric field at the point between the plates? So here electric field due to positive charge will be in this direction, that is, let us consider E, and due to negative charge is also in the same direction and its magnitude is also E. So actually here, since the electric fields are in the same direction, we have to consider A plus E is 2E, and at any point E is given by sigma by epsilon naught. Okay, sorry, sigma by 2 epsilon naught, that we have already done in the derivations. Electric field due to infinitely charged uniformly charged infinite plane sheet. So there you get sigma by epsilon naught. So here the answer is sigma by epsilon naught. Next, moving on to the question number 15. Here, what is the electric flux, total electric flux coming out of unit positive charge? Unit positive charge means what? Q value is 1. So is given by phi is equal to q by epsilon naught, called Gauss law. If q value is 1 divided by epsilon naught, so option B is the correct answer. Next, moving on to the question 16. Here there are three charges. First one is q plus capital Q, second one is q, third one is q minus capital Q. Are the charges enclosed by the surface S. What is the net flux crossing the surface? Let me consider the charges inside this surface, that is q plus capital Q, small q, q minus capital Q. So electric flux through the surface is given by q enclosed divided by epsilon naught. Means what is the total charge here? So total charge, if you want to calculate, let me consider q plus q plus q plus q minus q. Here capital Q get cancelled with the minus capital Q, and q plus q plus q is 3q. 3q by epsilon naught is the answer. So answer A, that is 3q by epsilon naught is the answer. Next, 17th one. A point charge Q is placed at a distance a by 2 directly above the center of the square. So there is a square here. Okay, there is a square here. At a particular distance, that is a by 2, a charge is placed. So how much is that? Small q. So what is the electric flux passing through this square? To apply this, to answer this, I am going to apply Gauss law here. So let me consider a Gaussian surface. We should know that to apply Gauss law, we should consider Gaussian surface around it. So what is the electric flux through this surface? So that is, we can answer it q by epsilon naught into 6, means 6 epsilon naught. This is Gauss law. Okay, next we have, which of the following graphs shows the variation of electric field due to a hollow charged spherical conductor of charge R as a function of distance from the center of the sphere? See, inside the sphere electric field will be 0. Outside it varies as 1 by r square, right? So inside 0 means you will be having 0 electric field till the radius r. So option A is correct. If you consider second one, see here there is linear increase in the electric field till r. No, it is not possible. Here also it is not possible, and this is also not possible. Electric field is 0 inside the electric charged spherical shell or charged spherical conductor. Option A is correct. See, if you know the basic concepts, if you have already studied the basic concept properly, then these concepts will be very easy for you. So the magnitude of electric field, we need to find out the magnitude of electric field E is such that an electron placed in it would experience a force equal to its weight. There is a force equal to its weight, that is equal to what? Q into E, right? This is the expression for force experienced by a charged particle placed in electric field. We know that electric field is defined as force per unit charge. So force is equal to what? Q into E. Here the charge is small e because an electron is considered, so charge will be E, small q is equal to E. So if you substitute that here, you will get E into E. Then what do you need to calculate? What is the electric field at that particular point? Means the magnitude of electric field E is such that an electric charge experiences force is given by, so here we have mg is equal to E into E. Let me solve this. Mg is equal to E into E. So they are asking us to calculate electric field, so that is mg by E. So that's why option B is correct. Very simple question. Okay, next. So repeated question, Gauss law basics, if you know, you can easily answer. What is, since the charge is placed at the corner, see, a charge capital Q is placed at the corner. Actually it is small q, not small q, capital Q. Here small q is there, or let us change here itself. Capital Q is placed at the corner of the cube. What is the flux of the electric field through the shaded region? What is the electric field through this region? Here, so one phase. So if you know the basics, you can easily answer. That is option B is correct. If the charge is at the corner, then the answer will be phi is equal to q by 24 epsilon naught for this question. Yes, we'll move on to next one. What is that? SI unit of permittivity of free space. See, farad is the unit for capacitance, Weber is the unit for electric flux. Here permittivity they are asking. See, permittivity, we know that F is equal to 1 over 4 pi epsilon naught q by r square, we have studied, right? So we need permittivity of free space, that is epsilon naught, that is equal to 1 over 4 pi, for this there is no unit, q by this is q1 into q2, q1 into q2 by r square is equal to, so for q1 into q2, what is the unit? Coulomb square divided by 4 force, it is Newton per meter square. So Coulomb square per Newton's per Newton per meter square. Where do you have the answer? Yeah, option C is correct. Coulomb square per Newton per meter square. Okay, na? Next. So next we have a few questions that I will cover in the next section. So in this video I am going to end to explain till question number 21. Still we have many questions to answer, that is theory based and CET level questions 33 are there. After that previous year CET questions are there, we will solve them also in the next videos. And then I have the list of questions for NEET also, JEE mains NEET level questions also there, so we'll solve them in the future videos. So we'll meet you in the next video. Till then, take care. Bye bye.